Hi, everybody. Thank you for joining our webinar today. We are going to discuss the GSG-7, the newest turnkey solution for the Skydel Simulation Engine. So first, I want to review our agenda, and then I'll introduce our speakers, and then we will get right into it. So what we're going to discuss today is first, what is the GSG-7? Then, how does it fit into our Orolia family of simulators? Then we'll go into some discussion on the architectural design. Then we will discuss the applications and use cases. Then some of the resources that are available to our customers and users. And then we'll do a Q&A at the end. So if you do have questions, then please feel free to add those to the questions panel during the event. If you lose connection, you can reconnect using the same link as you used to get here. And just so everybody is aware, this webinar is being recorded for those who are unable to join today. Following the event, we'll post the slides and the recording on the event page, and we'll send it out to those who have registered. At the end of the event, we'll do the Q&A, and that'll be our opportunity to review any questions you've submitted in advance or during the event. So our speakers today are going to be Pierre-Marie Leviel, our product line director for GNSS. And then we'll have Lisa Perdue, our principal solutions architect for GNSS. And I am your moderator, Patrick Bark, the customer experience marketing manager for Orolia. So without any other delay, Pierre-Marie, I'll pass it to you.
Thank you, Patrick. Okay, so the first thing to understand in the GSG-7 is that GSG-7 use exactly the same powerful Skydel engine that we use on all the Skydel simulators. Okay, so the GSG-7 use the same software with all the same feature you already enjoy to use in Skydel with the same performances. So for example, you will find the same graphical interface on the GSG-7 and the GSG-8 and other Skydel products. We support all the major global constellations, all the frequencies, all the signals. We have also, you always have the possibility to inject your custom signals, GNSS signals or LEO signals in the simulator. So Skydel is a real-time simulator, so you can change all the parameters of the simulation in runtime. So during the simulation, you can change the power or everything in the simulator in real time. You can also generate IQ files. So it's one powerful thing in Skydel. Instead of simulating RF signal, it's also possible to generate IQ file directly on the hard drive of the system, and then you can process this IQ file with different software to analyze the data directly in the numeric signal. One very nice feature we have in Skydel is that we support the 1000 Hz acceleration rate. So with this high rate, you can simulate any kind of trajectories from a vehicle trajectory to aerospace trajectory or missile trajectories. And finally, as you know, Skydel is really well known for the very intuitive API, so the interface to the Skydel simulator. So with this API, it's very, very simple in a few clicks to record all the action in the interface, and then record all this action in a Python script, for example, and then replay it in an automated script. So it's really, really simple to interface with Skydel, automate Skydel, and do very complex scenarios in Python or other programming language. So besides Skydel, GSG-7, it's also hardware. So the hardware in the GSG-7 has been selected to be on one side a very powerful hardware. So it's really a high-end simulator with high-end hardware. So with a very high-end graphic card, so we have the possibility to generate a lot of signals and basically simulate all the satellites in view of the receiver. So high-end graphic card, high-end radios. So we use the best COTS radio on the market to have the best RF quality in the simulator. And all this powerful hardware is installed in a 2U compact chassis. So the GSG-7 has the advantage to be a small and compact simulator. And with this high-end hardware, we still have a very cost-effective solution. So the GSG-7 is a powerful simulator, but in a very cost-effective and affordable solution to reach all the markets. So in the simulation product line family of Orolia, where is the GSG-7? So on the left, we still have the GSG-5 and 6 for essential simulation. And on the right, we have all the Skydel Simulation family. So all the Skydel simulator use the same Skydel engine. So as you know, it's possible to purchase only the Skydel engine. So in this case, you will have the Skydel software and you can purchase your own hardware to build your own simulator with the custom hardware you want to use. Or if you prefer, you can always buy COTS solution, so with including the hardware and the software. So for the COTS solution, we have now the GSG-7, the GSG-8, and the anechoic and wavefront system for CRPA testing. So GSG-7 and GSG-8, they both use very high-end hardware, high-end graphic cards, high-end radios. The difference, let's say, between the GSG-7 and GSG-8 in terms of number of graphic cards and the possibility to use the GSG-8 for resilience testing. Okay, so in the GSG-8, it's possible to use the GSG-8 to simulate jamming and spoofing scenarios when it's not possible in the 7. Except that the GSG-7 has all the same features than the GSG-8. So simulating a simple trajectory for telecom testing, for example, then more complex trajectories for automotive simulation. So the GSG-7, it's a perfect fit for autonomous driving simulation, for example, in a hardware-in-the-loop integrated environment. And the GSG-7 with the 1000 Hertz iteration rate can be used also for space simulation. Okay, so it's not only for static or small dynamic simulation, it's also usable for space simulation. So you can simulate aircraft trajectories or space vehicle trajectories with the GSG-7. So on this slide, we compare the architecture of the GSG-7 and the GSG-8. So both simulators use the same general architecture of Skydel, so based on CPU and graphic cards. So the GSG-7, we have selected the graphic card to be able to simulate all the GNSS constellations on all the signals and all the frequencies. So with approximately 200 signals, you have all the processing power required to simulate all in-view constellations. So all the radios in the GSG-7 are combined, and we output it on a single RF composite port. So instead of having several outputs, you just have a single output to connect your device under test. So on the GSG-7, we prefer to have a very simple system to use for the customer. On the GSG-8, there is a bit more flexibility with up to 2 graphic cards. We can generate also all the GNSS constellations and signal, plus jamming and spoofing scenarios or signals. And the radios are not combined to give more flexibility to the user. For example, selecting some radios for jamming, spoofing, and other radios for the GNSS signals. Okay, so the two systems, GSG-7 and 8, are based on the same architecture. GSG-7 is really designed to be very easy to use and complete system for 80% of the customers and all the customers that don't want to simulate jamming and spoofing. If we enter a little bit more in the details of the architecture, so if we open the box, inside the simulator, you will find always the graphic cards, so the high-end graphic cards for the generation of the IQ signal. Then you have 1, 2, 3 radios to generate the signal in RF. So with the 3 radios installed in the system, you can cover all the frequencies from L1, E6, L5, and L2. So we can cover all the frequencies to simulate all the signals in the simulator. Then in yellow, you have a timing card. So it's the clock reference for all the radios. It's a OCXO with a very high accuracy, and it's possible with the embedded receiver to calibrate the timing card on the external antenna to calibrate every year the simulator and the clock of the simulator. Then we combine all the signals from the AF cards inside the chassis, and we output the signal, the composite AF signal on the front panel of the simulator on a 8-type connector. So for the user, the only thing the user has to do is to connect the receiver with the AF cable to the simulator and click on start to play a simulation.
All right. Thank you, Pierre-Marie. So up next is going to be Lisa Perdue discussing our applications and use cases.
Thank you, Patrick. So when we look at Skydel and we talk about running Skydel on different platforms, such as the previous GSG-8 and now the new GSG-7, we're still just running the Skydel software. So I wanted to take the moment to point out the power of the Skydel software to show us the all-in-view satellites. So what I've done here is took the actual dates and time that you see here, which was at the end of September, a location in New York. I just was being lazy, so I just kept it with, round numbers. And you can see then with the elevation cutoff of 0 degrees, how many satellites are in view. And this is not anything hypothetical. This is how many satellites were in view at that location at that date and time. So we can see that we have satellites from the 4 main constellations, the global constellations, GPS, GLONASS, Galileo, and Beidou. And in this location, which happens to be, like as I said, in New York, we don't see any QZSS or Beidou satellites. But the number of satellites themselves, just from those 4 constellations in the sky at that time, is 44 GNSS satellites. And then we can take into account that each GNSS satellite transmits more than one signal. So there's the satellite itself, and it could be transmitting the open air signals, military signals, special message signals, multi-frequency GNSS signals. There's a lot of things that could be transmitted from a single satellite, more than one signal. So what I did here is take a shot at putting together this graph. Will show you how many signals are in the sky at this date, time, location with a 0 degree elevation cutoff. So we have satellites from GPS, GLONASS, Galileo, and Beidou. I did it by how many signals are on each satellite. So taking the example of GPS, we look at there's 4 signals per satellite we would be using maybe. So GPS L1CA, GPS L1C, GPS L2C, GPS L5. That's 4 different signals from a single satellite. So we do that math and multiply everything out, signals times number of sats, we get 179 total signals in the sky on this date and time. And these are just the GNSS signals. This is not even including multipath interference signals, S-band satellites. Those are not even included there. So that's why it's so important to be able to do a lot of satellites. The days of buying channel banks in, 8 or 16 at a time are pretty much over. There are just too many satellites to do things that way. So instead we use the software-defined architecture so that we can scale up the power where we need it. And then another application for the GSG-7 is using a simulator to simulate space launches. So putting something into space is not an easy task. And the biggest thing about it is you can't use the live sky to test it, right? You can't test at those speeds, at those altitudes on the ground. You need to actually launch the vehicle. But if we didn't test properly, something could be wrong and it could be even unfixable from the ground. So Skydel comes already with all these features that you need to do satellite simulation, including space launch and low Earth orbit satellites, medium Earth orbit satellites, geosatellites, whatever type of satellite orbit that you want to do. So we have a space vehicle orbital trajectory editor. we do take into account the different parts of the atmosphere that the signal is going to go to in order to reach the device under test. We do everything, as you've seen throughout the webinar, everything's at 1,000 hertz in Skydel. We never lower that. We can have a high signal count, which is important. The higher you go into space, you can start to see signals from the other side of the Earth. Especially in the geosatellite picture here, you can see that you'll actually be getting signals that would have normally been blocked by the Earth, but you're able to get them because the satellite is so high above the Earth. So we can model all of that. And we can even do the GNSS satellite antenna models. So when we talk about a system like GPS, there's multiple different versions of satellites in the sky, and those versions have different satellite models. So we could even go as far as to set up the proper satellite model per each satellite in each constellation. Kind of sticking on this flight theme here, another thing that we can do with the GSG-7 running our Skydel software is flight simulation. And this is really a hardware in the loop simulation setup, because if you can imagine that a user is actually going to sit in a cockpit of the vehicle that they're flying, a plane, and they're going to be performing the actions as if they were flying the plane. It's a flight simulator. So there's no way that in advance that they could record or know what the pilot's going to do. So we have to use hardware in the loop for this. Nice low latency hardware in the loop from the time that the pilot tells the plane to move in a certain direction or change one of its parameters, that we can send that to the simulator and have it reflected on the dashboard instruments of the cockpit of the plane as quickly as possible. So with Skydel, we can get our hardware in the loop latency down dependent on the hardware that you're running on and the OS that you're using. We can get sub 10 milliseconds testing on that. And that is very useful for our flight simulation, so that everything is updating in what appears to be real time. And that allows the flight to continue, the pilot to react to what's going on, and a whole closed loop system to do a full flight simulation where the instruments are performing properly as well. Now, you may have seen some of our presentations in the past where we said, this is how we can test RTK or RTCM messages. So this is really differential GPS. When there's correction data being sent from one receiver that's a base station to roving receivers, it could be multiple receivers, it could be over a network even, it doesn't have to be that local, to the rover or receiver under test to give it some correction information. So it says, I know exactly where I am, so I'm subject to error X, error Y. So this rover that's 1 kilometer away from me is also subject to these same errors. And I can take those errors and remove them from the rover and get much more accurate position. So that's what RTK is all about. And in our previous presentations, you've seen that we've said there's 3 ways to test RTK, and that's when we're using our GSG-8 or we're testing with our GSG-6, where we have the ability to use multiple RF outputs, whether it's synchronized units together, or in the GSG-8, use multiple RF outputs to simulate the base station and the rover. So with the GSG-7, with 1 RF output, we can still do RTK testing, but that we can do this method of RTK testing, where the GSG-7 is sending the RF information to the rover receiver, just as normal as a normal simulation. But at the same time, out of the data port, we're going to be simulating that correction data as if it was coming from a virtual base station. We'll be sending that over to the receiver under test, and that's how it's able to get its correction information and get that precise positioning that we're looking for out of RTK. So this method is still possible even with the GSG-7. So even though everything's internally combined and you cannot run 2 vehicles at once, we can still do Skydel RTCM messages via plug-in because we're not transmitting that over the RF, that's coming over the data port, which we can still do even with the 7. So if that's the type of RTCM testing or RTK testing that you're interested in doing, the 7 is a good fit for that as well. This is the RTK plugin screen in Skydel. So RTK, or are those RTCM messages that I just showed you on the previous slide, come through Skydel through plugins. So we do have this whole plugin ecosystem that we have additional material on our website, or you can just reach out to one of us. We could talk about it further, but I just wanted to show you what the interface looks like, and that the interface for a plugin does seamlessly integrate right into the Skydel UI. It's not another program running somewhere else. It's right in the same Skydel interface. You have your interface for the plugin, and in this particular plugin with the RTK, we can choose which messages that we want to send. We can choose to stream them to a serial port, which then you would configure. So you can stream right out of the GSG-8 if you put a serial port PCIe card in there or a USB serial adapter. You can stream to a port. We also include an Ntrip server caster. So Ntrip is the network-based RTCM messages, basically. But it's getting these messages, this correction messages over the network instead of being local, getting it via direct connection or over a radio frequency signal. And then finally, we can also just save the data to file for post-processing if we want to. So what this does is you set up your simulation, you say exactly the motion that you want the vehicle to do, any other parameters that you want to set, errors in the simulation, different type of atmosphere. You set up everything that you want, and then here the plugin is just going to generate the data based on its virtual base station and send it to the rover. So it's all integrated, it's all one thing, and it's all part of the plugin ecosystem. And that carries over into the 7 because it's part of Skydel. And with that, I think I'll pass it back over to you, Patrick, and let you wrap it up and tell us where we can find some more information.
All right. Thank you so much, Lisa. So first, I wanted to touch on a couple of the resources that we have out there for our users. The first thing we have are product hubs for our products. These are located at start.orolia.com, and they have things like support tutorials, FAQs, and things like that. It's a place for all of the items that we've built to help you get started with your product. The next thing we have is the user forum at learn.orolia.com. And this is a place for all of our users to collaborate, ask questions, learn from each other, discuss the plugins, discuss things they've run into, and is really just a community to build and learn off of each other. After that, we have our web resources like our blogs, webinars, use cases. Those cover a wide range of topics. After that, we have our knowledge base, which has all of our document-based information. So we have our data sheets, our user manuals, quick start guides, and application notes. Our application notes are built by our application engineers, and those cover different use cases that somebody might run into or features. A lot of them are walkthroughs of our products. After that, we have our GitHub at skydel.gitbook.io. And then we even have a Skydel certification course. So this is designed as a place for people to learn how to use Skydel, designed by our experts. So you can get certified. You can use it to train your new employees. You can use it if you are feeling a little rusty with the software or you want to make sure you use it correctly. And after that, we have our team of experts at orolia.com/support. So this is where you can put a ticket in to work with our support team, our applications team, our engineering team, our development team, any of those if you are having more problems that all of our resources can't solve for you. So now I'd like to take a moment to go over the questions that people have been posting in the questions chat. All right, so our first question is it possible to simulate LEO satellites with an antenna receiving Galileo HAS corrections for Galileo E1, E5A, E5B, and E6?
I can take this one if you want. So first about the signal simulation, yes, we do support all the Galileo signals. So we support E1, E5A, E5B, and E5 Albok even, and E6. And we also support the HAS correction from Galileo E6. And about the LEO simulation, so I guess the question is about the receiver embedded on a LEO satellite. So yes, we do support that. So as explained by during the presentation, we can simulate any kind of trajectories. So we can simulate trajectories on a LEO satellite with the dynamics on a LEO satellite. So yes, we can simulate these trajectories and these signals on the GSG-7 simulator.
All right, thank you. So our next question is, does it support L2C? And if so, how do I access them in real time during the simulation, such as a hardware in the loop scenario?
I think that's several questions in one.
Yes, I agree.
So, so do we support L2C? Yes. Okay, that's the easy part. Can you repeat the second part of that question though, Patrick? Let me make sure I understood it properly.
Yes, and I think this one is a bit complex, so I don't know if you'll be able to answer it in full, but we can give it a try. It is, how do I access L2C in real time during the simulation, such as a hardware in the loop scenario?
So I would recommend at this point then that you would just send us an email and we can talk one-on-one and try to figure out what the question is, because in that one question there.
Yeah, and that is the exact type of thing we tend to base our application notes on, is scenarios like that where we're walking the customer through something like that. All right, so our next question is, when working on real-time applications, what is the expected delay between commanded position and RF output?
So I can take this one if you want. So in other envelope, the latency, the total latency of the GSG-7 is below 10 milliseconds. Okay, so it's the delay between a commanded position to the simulator and the realization of the position and the RF output. So it's below 10 milliseconds. And we do have extrapolation algorithm in the simulator to get zero effective latency in the simulator. So we can compensate this 10 millisecond latency with extrapolation inside the simulator.
Thank you, Pierre-Marie. And the next question is antenna phase center a simulation parameter?
I can take this one also if you want. So yes, so we can simulate the receiver trajectory, of course, and we can simulate the location of the antenna relatively to the physical location of the receiver. And on the antenna itself, we can configure the antenna pattern. So we can configure antenna pattern for the gain of the signal, and we can also configure antenna patterns on the phase offset of the signal. So with these antenna patterns, we can simulate a variation on the phase center of the antenna.
All right, thank you. And here's a good one. Can the GSG-7 do multi-instance outside of RTK applications?
So no, we don't do multi-instance inside of GSG-7. That's what we would go to a GSG-8 for. So the only multi-instance that we do is the RTK, or as you can say, multi-instance that's software only, right? But you only have the hardware set to do one instance for one RF output.
All right, and somebody is now asking, what is the difference between the GSG-5, 6, and 8 compared to the 7?
Yeah, you just run back to the product family slide. Yeah, but I can start by just saying that the GSG-5 and GSG-6 are what we consider one family of products. So those are the original that Orolia was producing. So GSG-5, GSG-6 is a totally different product set than the GSG-7, GSG-8. So this Skydel simulator is what is powering our GSG-7 and our GSG-8 and even our wavefront and anechoic systems. So everything from Skydel on is all Skydel powered. And then we have our older family, which will be heading into retirement. Here, that's our GSG-5 and 6. So everything we've talked about today, everything we've looked at was all based around Skydel, which is what is running on GSG-7 and GSG-8. So to the left of the Skydel Simulation Engine, that's our older line of simulators. There's still a lot of good use cases for those simulators, but as GNSS gets more advanced, we need to increase the capabilities that we have in our systems to not only simulate what we have today, but prepare for the future, where now we're all starting to play in LEO, right? It was all MEO GNSS constellations, and now we're all starting to play in LEO. We're going to need this type of flexible, configurable simulation that the Skydel engine provides in these platforms in the future. So that's why we're heading that way.
Yeah, and we do have on our simulators page of the website a full breakdown of each one of these products, because it's not a short answer what the difference is between all of these. And that can be a conversation that we can have with somebody as well. But it is also worth mentioning that we have our Broad Sim product line that's also a part of the Orolia family of simulators. And those are the versions with the encrypted signals that are sold by Orolia Defense and Security. So there's a whole nother line that goes along with this same family.
And if you want more detailed information, we have that information available. We, just reach out to us in an email, and we can send you we can go over comparison charts and things like that with you.
Okay. We have another one here. What requirements, if any, do you have for periodic calibration of the GSG-7? If so, does this need to be done by Orolia?
So the requirements for calibration is we recommend calibration every 2 years. There's no reason to believe that the radios, the software-defined radios that we use in there, will drift. So basically, we're just doing calibration, which is just checking to make sure that everything's still within spec. So you can do that with the standard power meter. We give you instructions. So yes, you can do it at your own site. And then the other part of the system, other than power, that has to be calibrated is the timing. So in the GSG-7, it has the timing card in it that has a real easy to do the timing calibration. All we need to do there is hook up a GNSS receiver to the live sky when we're not simulating, and it will calibrate itself. So that part of it you can do yourself as well. So both the power and the timing calibration parts can be done at the user facility. It doesn't have to be returned to Orolia. Of course, we also provide that service though.
All right, I'm not seeing any other questions coming in here. So I think that is it for now. I'm pulling back up our question slide here. So if somebody does want to see some of the more in-depth specs of the product, the data sheet, the press release, all of that information is at the QR code on the screen. And if there are no other questions, thank you, Lisa. Thank you, Pierre-Marie. We appreciate you doing this for us and taking the time to answer all the questions for everybody. And thank you, everybody else who attended today. And we hope to hear from you soon.
Thank you, Patrick.
Thanks, everyone. Bye.
Thank you all.